The robot workforce, when machines take every job. Picture this, it's 3 a.m., a factory in Dongguan, China. No lights, complete darkness. Not because of a power outage, by design. Inside, robotic arms move with perfect precision. Welding, assembling, packaging, products roll off the line every 3 seconds. The factory produces 60,000 smartphones per day. Zero defects, zero breaks, zero human workers. They call it a dark factory, lights out manufacturing. Because robots don't need light, they use infrared sensors, cameras, LiDAR, vision systems that see better in darkness than humans see in daylight. This factory runs 24 hours a day, 365 days a year. It doesn't close for holidays. It doesn't have shifts. It doesn't have managers walking the floor checking quality. Because there is no floor to walk. Just machines building machines in the dark. And it's 30% more efficient than any human-operated factory has ever been. This isn't one experimental facility. China has dozens of dark factories. Japan has them. Germany is building them. Tesla's Gigafactory in Texas is 95% automated, and Elon Musk says the next one will be 99%. But here's what should terrify you. Dark factories are just the beginning. In a warehouse outside Memphis, Tennessee, 750 orange robots move in perfect synchronization. They don't walk, they glide, silently lifting entire 1,500-pound shelving units and carrying them across a floor the size of 28 football fields. One robot replaces 4 human workers. This facility has eliminated 3,000 jobs, and it's not even the largest. In California, a surgical robot named Da Vinci is performing its 10 millionth procedure. Its hands don't shake. It can make incisions measured in fractions of a millimeter. It operates for 18 hours straight without fatigue. The human surgeon is still there, but mostly watching. The robot does the cutting, the suturing, the precision work. The surgeon has become a supervisor. In Iowa, autonomous tractors plow fields with centimeter-level GPS precision. They plant seeds at optimal depth and spacing. They identify weeds using computer vision and eliminate them with targeted lasers. No pesticides needed. They harvest crops 24 hours a day. The farmer who used to employ 20 seasonal workers now employs 2 technicians who monitor the machines remotely. And on a highway in Arizona, an 18-wheel truck barrels down the interstate at 65 miles per hour. The cab is empty, no driver. The truck is hauling 40,000 pounds of cargo from Phoenix to Dallas, 900 miles, without a single human touching the wheel. A remote operator in an office 500 miles away can take control if something goes wrong. But mostly, the truck drives itself. There are 3.5 million truck drivers in the United States. It's one of the most common jobs in 29 states. And the technology to replace all of them already exists. Not in labs, on the road, right now. This is the robot workforce, not coming, here. And the wave that's about to hit the global economy will make every previous industrial revolution look like a minor adjustment. Because this time, it's not just factory workers, it's everyone. 1. The humanoid race, when one robot can do every job. For decades, robots were specialists. One robot welded, another painted, another assembled. Each machine designed for one task. If you wanted to automate a factory, you needed hundreds of different robots. That's changing. Tesla Optimus, the $20,000 human replacement. In September 2024, Elon Musk stood on a stage and introduced Optimus Gen 2, a humanoid robot. 2 legs, 2 arms, 2 hands, 5 fingers on each hand. It walks like a human, picks up objects like a human, and most terrifyingly, it can do almost any physical task a human can do. Musk's claim, by 2027, Optimus will cost $20,000 to $25,000, less than a used car, and it will be able to fold laundry, load dishwashers, carry groceries, assemble products in factories, stock shelves in warehouses, serve food in restaurants, clean buildings, care for the elderly. One robot, hundreds of tasks, for the cost of half a year's salary for a single worker. Why does a humanoid design matter? Because the entire world is built for humans. Doorways, stairs, handles, tools, kitchens, factories. If you build a robot in human form, it can use all existing infrastructure without modification. You don't need to redesign your warehouse for robots. You just replace the humans with humanoid machines. They use the same doors, the same shelves, the same tools. Therefore, a cheap, versatile humanoid robot doesn't just replace one job category, it replaces every job category that involves a human body doing physical work. Boston Dynamics Atlas, the robot that moves like an athlete. While Tesla focuses on cost, Boston Dynamics focuses on capability. In 2024, Boston Dynamics released footage of Atlas, their humanoid robot, doing parkour. Not slowly, not clumsily, parkour, running, jumping, flipping, landing with precision, moving with agility that would impress an Olympic gymnast. Atlas can lift and carry 45-pound objects while walking on uneven terrain, climb stairs, navigate construction sites, work in environments too dangerous for humans. Boston Dynamics robots are already being deployed. Spot, the dog-like robot, patrols oil rigs, inspects disaster zones, and guards military bases. Stretch, the warehouse robot, unloads 800 boxes per hour from shipping containers, a task that takes 4 to 6 human workers. Atlas isn't for sale yet, but when it is, it will work in construction, disaster response, military operations, and anywhere humans currently risk their lives doing dangerous physical labor. Therefore, the jobs that seemed robot-proof because they required physical dexterity and adaptability are no longer safe. China's Unitree G1, the $16,000 copycat. And then there's China. In 2024, Chinese robotics company Unitree released the G1 humanoid. Specifications nearly identical to Tesla's Optimus. Price, $16,000. Not $20,000, not $25,000, $16,000. China isn't just competing in the humanoid race, they're undercutting the competition by 20 to 40%, and they're manufacturing at scale that Western companies can't match. Why does this matter? Because once humanoid robots drop below the cost of a single year's salary for a minimum wage worker, the economic equation flips globally, not just in wealthy nations, everywhere. A factory owner in Vietnam currently pays workers $300 per month. That's $3,600 per year. If a robot costs $16,000 and works for 10 years, that's $1,600 per year. Even in the cheapest labor markets on Earth, robots become cheaper than humans. Therefore, this isn't about rich countries automating and poor countries staying labor-intensive. This is global, simultaneous, no place to run. 2. The dark factories. Manufacturing without humans. Let's go deeper into what's already happening. Not prototypes, not experiments, operating facilities. Fanuc, the factory that runs itself for 30 days. In Japan, robotics company Fanuc operates a factory that produces robots. The factory runs unsupervised for 30 consecutive days. 0 human workers on the floor. The robots build other robots. They self-diagnose errors. They order replacement parts automatically. They optimize production schedules using AI. Humans only enter the facility once a month to perform inspections and repairs that robots can't yet handle. Production output, 50 robots per 24-hour period. Error rate, 0.00%, compared to 2 to 5% in human-operated facilities. Why is this significant? Because it proves that robots can now build robots. The bottleneck in automation used to be that humans still needed to manufacture the machines. That bottleneck is gone. Therefore, automation is now self-replicating. The growth curve is exponential. Ocado, the grocery warehouse where robots do everything. In the UK, grocery company Ocado operates warehouses where robots fulfill online orders. The system is mesmerizing to watch. Thousands of robots move simultaneously across a grid. Each robot travels at 4 meters per second while carrying grocery crates. They communicate wirelessly, coordinating movements to avoid collisions. They pick and pack 65,000 grocery orders per week from a single facility. Human workers, 300, down from 3,000 in a traditional grocery warehouse. The robots work in 3 8-hour shifts, but unlike humans, they don't need all robots on all shifts. The system dynamically assigns robots based on real-time demand. During slow periods, robots recharge. During peak periods, 100% are active. The result? 90% labor reduction, 40% faster order fulfillment, near zero error rate. Therefore, the service economy, retail, logistics, food service, is automating as fast as manufacturing did. The jobs people fled to after factories automated are now disappearing too. 3. The autonomous vehicles, when 11 million jobs drive away. Now let's talk about the single largest category of employment about to be automated: driving. The truck drivers, 3.5 million jobs on the line. In the United States, truck driving is the most common job in 29 states. There are 3.5 million professional truck drivers. Add delivery drivers, taxi drivers, and bus drivers, and you're looking at 11 million jobs directly in the transportation sector. And the technology to replace them is already operational. Waymo, Google's self-driving car company, operates fully autonomous taxis in San Francisco, Phoenix, and Los Angeles. No safety driver, no human in the vehicle at all. You order a car via app, it arrives. You get in. It drives you to your destination. You get out. It leaves. Waymo vehicles have driven over 20 million autonomous miles on public roads. Accident rate, 85% lower than human drivers. Too Simple and Aurora are operating autonomous trucks on highways between Texas and California. The trucks drive themselves on highways. A human driver only takes over for the last mile in urban areas, but even that is temporary. Within 5 years, trucks will drive fully autonomously from warehouse to warehouse. Why does this matter beyond truck drivers? Because trucking is the economic circulatory system. If autonomous trucks are 30% cheaper to operate than human-driven trucks, and they are, no salary, no rest requirements, 24/7 operation, then shipping costs drop, product prices drop. Companies using human drivers can't compete. Human drivers are priced out of the market entirely. Therefore, autonomous vehicles don't just eliminate driving jobs, they eliminate an entire economic sector that employed millions and supported towns across rural America. The domino effect, when truck stops close. Here's the second-order effect nobody's talking about. There are approximately 5,000 truck stops across the United States. These are entire ecosystems: gas stations, restaurants, motels, repair shops, convenience stores. All of them exist because truck drivers need to stop, sleep, eat, fuel. Autonomous trucks don't need to stop for sleep. They refuel at automated charging stations. They don't buy coffee or meals. When autonomous trucks dominate, truck stops die, and the towns built around them, small towns in Kansas, Nebraska, Wyoming, Montana, die with them. Therefore, automation doesn't just kill individual jobs, it kills entire communities built around those jobs. 4. The economic singularity, when nobody can buy what robots make. Now let's zoom out to the macroeconomic problem nobody has solved: the productivity paradox. Capitalism works on a simple loop. Companies produce goods. Workers earn wages. Workers buy goods. Companies make profit. Repeat. But what happens when step 2 breaks? If robots produce everything and robots don't earn wages, who buys the products? Example: Tesla builds a fully automated factory. Robots produce 1 million cars per year. Cost per car drops to $15,000 because there are no labor costs. Great for Tesla, but the 10,000 workers who used to build cars are unemployed. They can't afford to buy cars anymore. Neither can the millions of other workers replaced by robots. Demand collapses. The cheap cars sit unsold in lots. This is the economic singularity, the point where automation makes production so efficient that it destroys the consumer base needed to sustain the economy. Why hasn't this been solved? Because no economic system in history has had to deal with mass unemployment by obsolescence. Previous technological revolutions created new jobs to replace old ones. Farm workers became factory workers. Factory workers became service workers. But when robots can do physical labor and AI can do cognitive labor, what jobs are left? Therefore, we are heading toward an economic structure that capitalism, as currently designed, cannot handle. 5. The solutions on the table, none of them easy. Universal basic income, paying people not to work. The most discussed solution is universal basic income, UBI. The government pays every citizen a monthly stipend regardless of employment status. Finland tested this in 2017 to 2018. 2,000 unemployed people received €560 per month with no strings attached. Results: mental health improved, happiness increased, employment rates stayed the same, people didn't stop looking for work. Alaska has had a form of UBI since 1982. The Alaska Permanent Fund pays every resident $1,000 to $2,000 per year from oil revenue. But scaling UBI globally faces problems. Cost: paying every American $1,000 per month costs $4 trillion per year, more than the entire federal budget. Inflation: if everyone has more money, prices rise. Meaning, humans derive identity and purpose from work. What happens psychologically when work disappears? Therefore, UBI might be necessary, but it's not sufficient. Money without meaning creates a different kind of crisis. Robot taxes, making automation pay for displacement. Another proposal: tax robots like you tax workers. If a robot replaces a $40,000 per year worker, the company pays $10,000 per year in robot tax. That revenue funds UBI and retraining programs. Bill Gates proposed this in 2017. South Korea implemented a version in 2018. But companies will fight this. It eliminates the cost advantage of robots. How do you define a robot? Is Excel a robot? Is an autonomous truck a robot? Is AI a robot? If one country taxes robots heavily, companies move production to countries that don't. Therefore, robot taxes sound good in theory. In practice, enforcement is nearly impossible. The radical solution: shorten the work week. What if instead of UBI, we just redistribute existing work? If robots can do 50% of work, then humans work 20 hours per week instead of 40. Same total employment, half the hours per person. France tried this with the 35-hour work week in 2000. Results were mixed. Employment increased slightly, productivity per hour increased, but total economic output didn't grow. Therefore, redistributing work prevents unemployment, but it also means everyone earns less. And in a competitive global economy, the country that works less loses to the country that automates more. 6. The three futures. Future 1. The automated abundance technology solves the economic problem. Energy becomes nearly free, fusion power. Production becomes nearly free, robots. Scarcity ends. Humans work not because they have to, but because they choose to. UBI provides basics. People pursue art, science, community, meaning. Society transitions from capitalism to a post-scarcity economy. This is the optimistic scenario. It requires technological breakthroughs that haven't happened yet, political systems that redistribute wealth equitably, humans finding meaning without economic necessity, probability low, but technically possible. Future 2, the divided world. Automation happens unevenly. Wealthy countries automate fully, poor countries stay labor-intensive. But within wealthy countries, sharp class divisions emerge. The owner class, people who own robots and AI, become incomprehensibly wealthy. The displaced class, people whose jobs were automated, live on UBI, comfortable but powerless. A small technical class, people who maintain robots and AI, remain employed. This is neo-feudalism, not based on land ownership, based on capital and automation ownership. Probability high. This is the current trajectory. Future 3, the collapse. Automation happens too fast. Governments can't adapt. Unemployment spikes. Social safety nets collapse. Mass unrest. Political instability. Economic depression. Possibly violence. Governments respond with authoritarian control, banning automation, impossible to enforce, or collapse entirely. This is the dark scenario, not because technology failed, because society failed to adapt to technology. Probability, moderate, and rising with every year of political paralysis. 7. Final thoughts, the species that built its replacement. So that's the story. Humanity spent 10,000 years building tools. Then we built tools that could build other tools. Then we built tools that could replace us entirely. The dark factories are running. The robots are rolling off assembly lines. The autonomous trucks are driving highways. The humanoid machines are learning to walk, to grasp, to work. And most people still don't know it's happening. Not because it's secret, because it's quiet. Because automation doesn't happen with announcements and press conferences. It happens in warehouses at 3 a.m., in factories across oceans, in software updates, in purchasing decisions made by executives you've never heard of. By the time the public fully understands what's happening, it will already be done. Why does this matter to you? Because your job, whatever it is either already automated, being automated right now, will be automated within 10 to 15 years. Unless you own the robots, you are competing with the robots. And the robots are cheaper, faster, and they never stop improving. The robot workforce isn't the future, it's now. And the question isn't whether it will happen. The question is, what do we do when it does? If you want to understand what happens when the machines don't just take jobs, when they take purpose, stay tuned. Subscribe to Deep Research, because understanding what's coming is the only advantage you have left. Thanks for watching. See you in the next one, if humans still have a next one.